Amazing news about the mRNA COVID vaccines, as well as saving millions of lives during the pandemic. It turns out they also help our bodies fight cancer.
And this seems to be a general property of all mRNA vaccines.
They did this whole bunch of study in mice that showed that mRNA vaccines in general seem to have this anti-tumour effect.
So we're going to get into the details of this brand new finding today.
Also on the show, we hear from the authors of the State of Climate Action 2025 report.
So spoiler alert, I imagine we're not doing very well at all.
We're not doing very well. And in some cases, we're going in the wrong direction.
So if this was like a report card, we've kind of flunked out on everything.
And we have a new explanation for the dawn chorus.
Yes, why birds almost universally call in the new day with this chorus of singing. And it turns out that's actually still a bit of a mystery.
It's nighttime, they have to hold in all the singing, and then at dawn it just flows out of them.
Don't sing, don't sing, don't sing, go!
Yeah. This episode is sponsored by Yakult, the gut experts for over 90 years.
Welcome to The World, the Universe and Us. I'm Dr. Penny Sarche.
And I'm Dr. Rowan Hooper.
Now, it's been estimated that the mRNA COVID vaccines saved 14 million lives in their first year of use alone.
Wow.
And that provided economic benefits, if that's how you see the world, up to $38 trillion.
Wow.
Massive, right?
Yeah.
But now it appears they might have another benefit too, helping our bodies to fight cancer. Michael LePage has reported on this for us, and this seems extraordinary. Michael, what's the story?
Yeah, so the immediate news this week is a study that looked at the records of nearly 1,000 people who have been treated for advanced skin and lung cancers. Now, some of those people were given an mRNA COVID vaccine within 100 days of starting immunotherapy, and they lived nearly twice as long. Now, we're talking sort of months and years. This is not a miracle cure, but it's a pretty big effect.
Yeah, you'd definitely take that at that stage.
Absolutely. Now, of course, we do need to be cautious about this. It's been suggested, for instance, that maybe the people who got vaccinated were healthier to start with. But there have actually been case reports of people with cancer improving after a COVID shot. And the team behind this study have already done animal studies suggesting that not only is this effect real, it's a general property of mRNA vaccines, not just of the COVID vaccines. So it's not just a single study. There are several lines of evidence, and the next step is going to be a randomized controlled trial.
Okay, so that is very promising. We do need to, as you say, wait for this proper randomized controlled trial. But Michael, take us back to the basics of mRNA vaccines and remind us how they're different to normal ones.
Yeah, so normal vaccines contain either viruses or viral proteins. The problem with this is that viruses and viral proteins can only be made by living cells, and then you've got to purify them to make the vaccine, and that takes time and it takes money. Mm-hmm. Now, with mRNA vaccines, you just give cells the recipes for making proteins, and you let those cells do the hard work of making the proteins. Those recipes just break down after a few days, by the way. They don't hang around in your body. So the way I think of it, it's like the difference between a friend calling up and saying, hey, I really fancied that dish you cooked the other day. Can you make it for me again? Or maybe they call up and say, hey, can you send me the recipe for the dish I liked? Now, one's a lot easier, which is why the COVID mRNA vaccines could be rolled out so fast.
That's great. I like that. And so what about the immunotherapy? How does it work there?
Yeah, immunotherapy is just a term for any treatments that boost the immune response to cancers. But with this study, we're talking specifically about drugs called immune checkpoint inhibitors. Now, the way they work is like this. As cancers evolve in our bodies, they often become resistant to immune attacks. And they kind of do this by putting these signs on their surface that say, hey, don't attack me, I'm part of you, I'm friendly, leave me alone.
Yeah.
Now, unfortunately, our immune cells are dumb enough to believe that. So what checkpoint inhibitors do is they stop those immune cells seeing those signals. They kind of blind the immune cells, so they just carry on attacking instead of stopping.
And when they work really well, don't they? We had a piece a while back on just how these have transformed cancer treatments, these checkpoint inhibitors.
Yeah, they've been absolutely transformative in some cases, but unfortunately they don't work for everyone. So if your immune system isn't already sending out cells to attack tumours, these drugs can't help. So that's where cancer vaccines come in. Now you think if you can combine cancer vaccines that stimulate your immune system to attack the tumours with these checkpoint inhibitors that make sure that attack carries on, then you get much better results. But of course, the problems with cancer vaccines too, and the main one is that they often have to be specific individuals. They have to target their unique cancers. And of course, that's expensive and it's time-consuming, even if you're using mRNA vaccines. But what this team led by Elias Sayour at the University of Florida noticed while they were doing trials of cancer vaccines. They were using non-specific mRNA vaccines as controls. Now, these were not supposed to do anything. They were just supposed to be controls, but it turned out they were doing something. So the team then were going, what's going on? And they did this whole bunch of study in mice. And these are the studies that showed that mRNA vaccines in general seem to have this anti-tumor effect. So the way Sayour told me about it is he said, you can imagine that those T cells that are supposed to be attacking the tumor, when they see these don't attack signals, they're just sitting there in the tumor and they're doing nothing. And when the mRNA vaccine comes along, it's like sounding a siren, and those immune cells that are just sitting doing nothing then migrate to lymph nodes and they talk to other cells and they sort of stimulate this broader attack on the tumor. But anyway, so the team realized, hey, if these results are right, if mRNA vaccines do have this effect, then the COVID mRNA vaccine should do this too. And that's why they went and looked at the records of these people with advanced cancers and found, oh yeah, it does look like there's an effect.
So there'll be some people listening who might be doing immunotherapy. They might be about to go on checkpoint inhibitors. They'll be wondering if they should go out and get a COVID vaccine.
The obvious thing to say here, this is something they should talk to their doctors about. So what Sayour told me is that we need to wait on results of that randomized controlled trial and that people should follow the existing guidelines for using these vaccines until then. But obviously, it's already standard practice for some people to get COVID vaccines while on checkpoint inhibitors. So that doesn't mean people can't take them, but just get medical advice.
And then if the trial does confirm this effect, what then? Can you sort of foresee mRNA vaccines becoming part of sort of standard cancer immunotherapy treatment?
Yes, I mean, I think we're going to have to wait and see. It's possible, but I think in the long run, the aim is to understand exactly why mRNA vaccines have this effect, and then to try and develop specific vaccines that maximize it, that boost this effect even more.
I feel I have to ask, there was some trepidation amongst even people who aren't vaccine skeptics or anti-vaxxers when we had this entire new vaccine technology come out. And I do wonder if some people will hear that there's this kind of positive effect, but it's an effect that we don't really fully understand and it's not one that we predicted. Does that in any way make us a bit more nervous about mRNA vaccines, that they might do things that we didn't realise?
Yeah, I think that's a good question. So for me, the first thing to say is, apart from preventing the disease in question, vaccine trials are not designed to pick up good side effects. They're looking for the bad ones.
Yeah.
The second thing to say is, we need to take a step back and think about the broader perspective. What I mean is lots of viruses can have really nasty side effects that were not expected. So take Epstein-Barr virus, which is what causes mono, or what's often called kissing disease. In the past few years, we've got really strong evidence coming out that Epstein-Barr is the cause of multiple sclerosis. And of course, one of the things that came out of all the studies of long COVID is that it's not just COVID that can have serious long-term effects. It happens with lots of viruses, including the flu. So the point I'm trying to make is, the question to ask is not, are vaccines 100% safe? It's, am I safer if I'm vaccinated than if I'm not vaccinated? Now, can vaccine trials pick up every single possible side effect? No, but they can pick up enough for us to be sure that the vast majority of people are better off with the vaccine than without it.
And this does certainly help counter some of the misinformation that's been going around, especially about mRNA vaccines in the US. It might end up being, like, as you say, that we don't use specifically the COVID vaccine against it, but we use some kind of mRNA vaccine against cancer. But I hope this is really becomes a positive story. It makes people think, actually, there are these extra good benefits from it.
Yeah, absolutely. I mean, I hope that's the case. I suspect that with some of the people, they're not there to listen to logic and reason, and that it's not going to make any difference. But I think it's good maybe to finish on the point that we were talking here about mRNA COVID vaccines, but we've also discovered that some other vaccines have sort of beneficial side effects recently.
Yeah.
So take the flu vaccine. There was a study recently that shows it seems to reduce the risk of a heart attack in a year after you take it by a third. And the shingles vaccine has got all sorts of other benefits. So it appears to reduce heart attacks and strokes and dementia. And I think this makes sense because, as we said earlier, viruses can have all sorts of nasty effects and damage our bodies. So if you're preventing these infections with vaccines, you're preventing that damage.
No, that does remind me, I have to get my flu vaccine. I've seen it up around the office.
Flu and heart attack vaccine, all in one.
Excellent. Did you know that Yakult has an amazing amount of science behind its iconic bottle? Yakult's founder, the Japanese scientist Minoru Shirota, spent many years investigating intestinal bacteria. He selected and cultivated a unique strain of friendly bacteria, L. casei shirota, and in 1935, the first bottle of Yakult was produced. Fast forward 90 years, and Dr. Shirota's work is continued with passion by hundreds of scientists and researchers seeking future applications for this unique, friendly bacteria. For more information, visit yakult.co.uk.
COP30 is coming up in Brazil in November, and that's the 30th UN Climate Change Conference. The 30th.
Yeah.
It also happens to be 10 years since the historic Paris climate meeting, where countries agreed to at least try to limit global heating to 1.5 degrees. Ahead of COP30, the World Resources Institute and a few other places have published the latest State of Climate Action report. And Rowan, you've been digging into it. Has it made for nice reading?
Not what I'd really go to bed with, no. It's actually a horror show coming up to Halloween.
Yeah, perfect timing.
It's a report about assesses how we're doing in terms of meeting those milestones that were put down during the Paris Agreement.
So spoiler alert, I imagine we're not doing very well
We're
at all.
not doing very well. So there's 45 indicators of what we need to do to stay at 1.5. None of them are on target. So there are things like what we need to do for power, buildings, industry, transport, forests and land use, and food and agriculture, of course. And we're not moving fast enough to meet any of the goals for those things. And in some cases, we're going in the wrong direction.
Right. So if this was like a report card, I mean, it is a report card on our progress. We've kind of flunked out on everything.
We completely failed. And I think it was last week we said, there is a climate emergency that everyone's shouting about. We're not acting on it. So this is yet more red alarms flashing. And we're seeing a growing aversion to calls for transition to net zero emissions when it couldn't be clearer again and again that we have to get to net zero as fast as we possibly can. So, yeah, as I say, there's 45 things that we're failing at. And I just want to pick out a couple that jumped out at me as being particularly bad or surprising. One was deforestation. So alone, that accounts for 10% of global greenhouse gas emissions. And the report, again, so it finds that we're not moving fast enough to stop that. And for mangroves in particular, we're going really bad with those. And of course, it's not just the carbon stored in forests and mangroves, it's the biodiversity that we're losing as well. The report finds that we need to reduce deforestation 9 times faster than we are. And this is shocking. We're permanently losing nearly 22 football fields of forest every minute. Every minute? Yeah.
God, that's devastating.
It's just tragic. Coal is another one. So, last year we celebrated the closure of the last coal-fired power station in the UK. And sometimes you think, we've reached peak coal, but we're not. Globally, coal has not peaked at all. And I asked Claire Schumer at the World Resource Institute about this. She's lead author or co-lead author of the report. And here she is.
For the 5th report in this series in a row, we find that efforts to phase out coal are well off track. You'll see in our report that coal's share of global electricity dropped slightly in 2024, but total coal use hit a record high last year because of growing overall electricity demand. Coal remains by far the largest source of greenhouse gas emissions in the power sector, along, of course, with gas, which is more prominent in certain geographies around the world. And the trouble here is that a power system that relies on fossil fuels has huge cascading and knock-on effects for other end-use energy sectors. Decarbonizing buildings, decarbonizing industry, decarbonizing transport, they all depend on a decarbonized power grid. So the message on this really couldn't be clearer. We simply will not limit warming to 1.5 degrees if coal use keeps breaking records. To get on track, we find in our State of Climate Action report that the world needs to phase out coal power generation more than 10 times faster than current rates, which is equivalent to shutting down nearly 360 average-sized coal plants every year and scrapping every project that's in the pipeline.
That's a lot. 360 plants a year.
Closing. And also, importantly, cancelling everything else.
Yeah, everything else that's
still
being
people
built.
sort of scratching their heads going, we're considering prospecting or opening this new... No, cancel them all. Completely incompatible with the future. Not forget 1.5 with an acceptable future.
So this all sounds incredibly damning. Was there any kind of glimmer of good news or hope? Come on.
There is a tiny bit, but let's get the bad news, the even worse news out of the way.
Oh, no.
So climate finance, that's the money that's provided to mitigate or adapt to the climate crisis. That's still, they find, still pitifully low and needs to increase to almost $1 trillion a year, which is great if that ever happened. That would be 2/3 of the money, the public money that the fossil fuel industry gets in subsidies.
Gosh. But private finance for climate is increasing, right?
Private finance is, yeah. But what we need is state-level action, because private finance is all fair enough and does some nice things, but we need state-level action. The other co-author of the report was Sophie Boehm, and I asked her about that, and here she is.
So I am really concerned because we are seeing global efforts to mobilize climate funds from the public sector starting to stall and potentially even backtrack. Between 2022 and 2023, for example, public climate finance actually fell from $740 billion to $650 billion. And to make matters worse, public finance for fossil fuels has actually risen by $75 billion per year since 2014. And this is just completely unacceptable given countries' commitments under the Paris Agreement. Public funds should be at the cutting edge of climate finance, not propping up fossil fuels. So governments must course correct immediately, shifting public finance away from fossil fuels and toward climate solutions.
So there's a sort of elephant in the room here. We're talking about Paris 10 years ago and 1.5. But we basically know, don't we, that we have breached that 1.5 goal.
1.5 has gone, and we are still talking about, this vastly theoretical target that people say let's still keep it alive.
Yeah.
So no, it is gone. But it also made me think about the whole value of the COP system, which has also become eroded. Our trust in the COPs has become eroded over the years. I also asked Sophie about that. She wants to say there is still value in having them, and here she is on that.
The brilliance of the Paris Agreement was that while countries' commitments would be nationally determined and not legally binding, the reporting rules would be. So the theory was that as countries submitted their national pledges and then publicly reported progress against them, ambition would ratchet up over time. And we have seen this come to fruition. When the Paris Agreement was first adopted, the world was on course for roughly 4 degrees Celsius of warming. But countries' current pledges have lowered that figure to between 2.1 and 2.8 degrees Celsius. Of course, that's assuming that they're fully implemented. So while I do agree that a shift is underway at the COPs, we are seeing countries move away from negotiating the rulebook of the Paris Agreement and toward implementation. I still think that these conferences can provide a helpful space for holding countries accountable to the Paris Agreement goals, whether that's through a global stock-taking process that occurs every 5 years, or through countries reporting back on their efforts to date and respective impact on greenhouse gas emissions. And reports like the State of Climate Action can play a critical role in informing these stock-taking exercises. For example, showing just how far behind global efforts to phase out coal, halt deforestation, or scale up climate finance are, as well as what's needed to get back on track.
I do agree with her there. I reported on Paris for New Scientist, and at the time I was very skeptical. I saw the whole thing. Yeah, I saw the whole thing as a giant exercise in greenwashing, and really didn't think it would achieve much at all. And well, it hasn't achieved what it set out to do, but it has done more than I thought it would. So from that point of view, I think it was worthwhile. And there's been some progress, not enough, but there's been some progress.
COPs can be quite dispiriting affairs, though, can't they? There are so many fossil fuel lobbyists. The petrostates are there, and there's a lot of skepticism now. I mean, yes, I take that we are on track for a less worse scenario than we might have been. Yeah. But there's a lot more skepticism and this feeling about COPs have been captured by corporate interests.
Yeah, and it's not just that as well, is it? It's just the whole shebang.
Yes.
All these targets that we're missing.
Yeah.
And all the floods, the wildfires, everything we're seeing all the time, it can be super dispiriting.
Yeah.
And I often ask climate scientists and policy wonks about this. How do you get through the day?
Yeah.
And how they tread the line between despair and hope. And I of course asked Sophie about this as well. Here's her answer.
It really is such a difficult line to tread, but I do think it's all about perspective. So looking back to 2015, when the Paris Agreement was formally adopted, it's clear that a truly remarkable transition is underway. A decade ago, I'd never even seen an electric car, let alone ridden in one. Now, there's almost one on every street corner in my city. And globally, more than 1 in 5 cars sold today are electric. Equally impressive, wind and solar share in electricity generation has more than tripled since 2015. And some technologies that were no more than ideas or very small-scale pilot projects back when the Paris Agreement was adopted are now being deployed around the world. This progress is incredible, and it shows that rapid change is not only possible, but already well underway in some sectors. And I do think that that's worth celebrating. But looking ahead to 2030, it's clear that we still have such a long way to go to combat the climate crisis. As our report shows, we're not just falling behind across every single sector. We are effectively flunking the subjects that matter most. Phasing out coal, halting deforestation, ending public fossil fuel finance. These are some of the most impactful things that we can do. And yet in the 5 years that we've been issuing this report card, we've barely moved the needle on any. So I do think it's possible to be clear-eyed about the challenge ahead. It is immense, and the scale of changes required are unprecedented. But just because something is unprecedented doesn't mean it's impossible. I still have faith in humanity. I still think we are capable of rising to the occasion. The solutions exist. We know what to do. We just need to act with the urgency that this moment demands.
So that's your grain of good news that we'll try and end with. But that line, I do like that line.
Yes.
Just because it's unprecedented, it isn't impossible.
I've said this before on the podcast, but, every bit helps. I think, we shouldn't just give up and go, oh, we're not doing enough. We've got to, it's no good. It's all hopeless. It's not hopeless. Every bit we do helps. Every little bit of warming that we avoid in sort of the future is that much better for us. So don't despair. Keep going.
So whenever I'm sad or depressed, as I might be about the state of the climate, there's one thing that just calms my brain, and that's birdsong.
Yeah.
Isn't that beautiful?
You just play out the whole rest of the show.
Yeah, the rest of the episode is birdsong, guys. We're listening to a clip of the Dawn Chorus recorded from some of the RSPB's nature reserves here in the UK. Thank you to the RSPB for the audio.
There was a cuckoo.
Yeah.
Listen to that. So this is a story about explaining what we're listening to, the Dawn Chorus. Yes,
why birds around the world, almost universally, call in the new day with this chorus of singing. And it turns out that's actually still a bit of a mystery.
So I knew there were lots of different explanations for this. I looked into this, and there were 11.
11?
More than I thought, including the female manipulation hypothesis. That's the one that says males sing to make females fertile or to persuade them to mate.
Right.
Then there's the honest signal of condition hypothesis. It's what it says on the tin. It's like,
I'm brilliant.
I can sing because I'm in good condition. Again, so come and mate with me, or don't intrude into my territory. Or it could be the territorial dispute, which is called the social dynamics hypothesis, like keep out of my place.
And then there's also this absent mate hypothesis, which was tested in blue tits. It suggests that males sing at a higher rate whenever they're separated from their mate, and that song rate increases with the duration of female absence. Aww. But this is a new one. We're talking about the suppression and rebound hypothesis.
Yeah, so the idea here is that it's nighttime, they have to hold in all their singing, and then at dawn it just flows out of them.
Don't sing, go.
Yeah.
I love this one.
So this has now been tested in zebra finches in the lab, and zebra finches, as you may know, they're really well-studied lab birds, especially for things like neuroscience and singing.
Yeah.
And in the lab, you can control their environment. You can increase and decrease the length of their nights using artificial lighting. And when scientists at the Korea Brain Research Institute did this, they found dramatic changes in the dawn chorus singing behaviour. And their findings suggest that darkness leads to an increasing build-up over the nighttime period in their desire to just let rip and sing.
Yeah, I'm struggling a little bit to believe it, but
go on.
Yeah,
yeah, same. But it's very interesting.
Yeah.
What the team did was they first pushed back the time at which the finches were exposed to light to 3 hours later than the actual dawn. And so the birds, found themselves waking up, but they stayed silent in that artificial darkness. However, when the lights eventually did come on, the birds sang way more intensely than usual. So it's like it built up in them even more. And then when lights on time, so artificial dawn was 3 hours earlier than true dawn, the birds still broke into a chorus, but without quite the same intensity as if they'd been forced to wait.
Half-heartedly.
Yeah, so in other words, the longer the time between when the birds wake up but remain in the dark, the more intense the dawn chorus. So it potentially, it is building up to some kind of level and just waiting to come out.
All right. So this is still completely mechanistic, like the underlying reasons for it, rather than the, I think, more interesting functional evolutionary explanation of why they do it.
Yeah, that's right. And we'll get to that. Satoshi Kojima, one of the scientists on this study, told our reporter James Woodford that the birds are already awake in the dark before the lights come on, but their spontaneous singing is suppressed by the darkness. This suppression elevates their motivation to sing, leading to a high rate of singing as a rebound immediately after the lights are turned on.
It is a bit like sleep, isn't it? And they talk about sleep pressure, don't they? Sleep scientists.
Melatonin builds throughout the day.
Is it similar to that?
Yeah, I guess it's similar, like a sort of song pressure. When the scientists blocked the effects of melatonin in these birds, that did actually make them wake up more quickly. And the birds began singing earlier than those in the control group. So it does suggest it's kind of plugged into that sleep system that we have.
Okay, so that's a kind of hormonal mechanistic thing. What about the function of it?
So they approach that by analysing song structure. And their idea is that dawn calling allowed the birds to finesse their songs after the night before.
Really?
Yeah. So there were rapid changes to the structure of the birds singing in the first hour after dawn compared to the second. So there's this idea that due to an absence of singing during the night, the vocal motor system and song acoustic structure may deteriorate, maybe. Yeah. And then the dawn chorus serves to quickly restore or optimize them, like turning it back on again.
So, like if I wake up and have to speak immediately, I'm like
croaky and you're struggling to find your words.
That's the rough analogy.
But maybe you just want to sing something different in the second hour of the dawn chorus than the first. So I'm not sure. Yeah. And zebra finches, they're a great lab model for studying the neuroscience of song. But can they really tell us why so many species sing? And they don't just do it at dawn, they do it at dusk too. And also it's seasonal. Like in the UK, the spring dawn chorus is way more spectacular than the rest of the time of year. But it is a neat experiment. They controlled so many factors. And underneath it all, this sort of hormonal bounce effect is pretty cool.
Yeah.
There's suppressed urge to sing throughout the night and this sudden sort of release in the morning. So let's go back to the absent mate effect, though.
Yeah, so that was done on blue tits.
Was that the sort of classic White and Woods study in Oxfordshire? There's a lot of blue tit work there.
Yeah, there is loads. This particular one was done in Germany.
Right.
And the idea is that you get a dawn and dusk chorus if females leave the roost later in the morning and then go to roost in the evening earlier than their mate. And the German study found that males sing at a higher rate whenever they're separated from their mates.
Aww.
And that song rate increases with increasing duration of female absence.
So that still doesn't sort of narrow it down much or fully explain it, does it? Singing because the female is absent, we still don't really know if that's to show off their condition or to try to find another mate or bring back their mate.
Extra pair copulation.
Absolutely, quite common in birds.
Yeah, and also, why don't other animals do that? I mean, there are lots of other like mammals and monkeys that sort of sing or boom, or do they do dawn choruses? I can't think of any.
There are some other animals that do a sort of dawn chorus. Nothing is spectacular.
I feel like howler monkeys calling in the jungle first thing is a thing, but I don't know if I'm remembering that right.
Yeah, but again, then that's just one species of monkeys, and this is all the birds doing it. So
I'm just grateful that humans don't do it.
I mean, there are lots of different hypotheses. They're not all mutually exclusive.
No,
but might all be going on, even including this rebound thing as well.
And there's still quite a lot we don't know about birdsong. It's only recently that we've realised females sing quite a lot too. We used to just think it was a male thing for some reason. Yeah. So there's still loads to find out.
Yeah, get out in the field and do some more work.
Yeah, lucky biologists.
Well, we'll leave that playing as we say goodbye.
Yes, that's all for this week. Thanks to our guests and thanks to you for listening.
And we'll be back next week. Bye for now.
Bye.
Bye.
Little tweet there. Bird saying goodbye. This episode was sponsored by Yakult, the gut experts for over 90 years. For more information, visit yakult.co.uk.